Hi, I'm Jack Mazurek, and this is my presentation on how we could stop an asteroid from hitting Earth. So there are three main ways to stop an asteroid: using a laser, using a nuclear bomb, or using kinetic energy. What would be the most efficient way to stop an asteroid? It depends on the situation. If the asteroid is made of ice, then a laser would do best. But if it is mostly irony and rocky, then a laser would do almost nothing. So it depends on how much time we have and how it is formed. Who would be in charge? Most likely the UN or United Nations would be in charge. This would help so that all countries have a say, and there's a treaty about weapons in space which the UN could waive since it was made by them. So how could we use a laser to stop an asteroid? It depends. If the asteroid is made of ice, then yes, it would be easy. A laser would heat the asteroid and the steam would slowly push it in the opposite direction. Since if the steam is moving away, it will continue to slowly go in the opposite direction. And if it did hurt Earth, the asteroid could burn up because it's melting and it would have so little surface area and mass left. And where would we put this massive laser? The easiest and most efficient place to put it would be on a satellite floating just outside the Earth's orbit. If it was inside the Earth's orbit, then it would have to constantly adjust its angle, and half the time it would be behind the Earth so the asteroid could cool, and it would make it twice as long. Pros: useful with an icy asteroid, low cost. Cons: we would have to know a long time beforehand, and it would not help if it's metally or rocky. It would be hard to power, and it has to be assembled in space. Could we use a nuclear weapon to stop an asteroid? A nuclear weapon would be subsurface at about 1,000 feet from the surface. This would be so the asteroid does not fragment from too much pressure, since if the asteroid does fragment, it would be more like a radioactive shotgun blast head for Earth. To deflect the asteroid, we need a rocket like a Falcon 9, which is a rocket that can lift a lot of weight, and we would also need a fission or fusion bomb, which the US or another country would likely supply. The most challenging part would be to hit the asteroid, since the timing would have to be accurate to the 10th of a second. Pros: we'd not need that much notice since we can change the angle. It would move the asteroid away from Earth very quickly, and the USA and other countries have the technology. Cons: if it does not work, it would become a radioactive shotgun blast. It would have a chance to fragment, and if it was too close to Earth, it would be a radioactive fallout, and there would have to be a change to a treaty with over 150 countries signing it. Could we use kinetic energy? What would it look like to use kinetic energy? To use kinetic energy, we would make a giant ram out of a spaceship and hit it at a certain angle so the asteroid would miss Earth. One of the major advantages with this is that it would work with any kind of asteroid and could be used if we have lots of time or little time. So pros: medium cost and very little notice needed, and it would be cons: it would be hard to get at the right angle, and it would be kind of expensive. Conclusion: from my point of view, I think that in most situations, kinetic energy would be most useful. This is because it will not break the bank if the asteroid is headed for a country that cannot help pay for it, and some countries that do have are more wealthy can help fund it. This is also so that the asteroid is not toxic to humans. We also would not have to see the asteroid too far in advance, since we can adjust the angle of the ram. But in a situation where the asteroid is icy, I'd suggest a laser. So just a little bit more in depth on how we would use the spaceship as kinetic energy is we would pretty much send out multiple spaceships and hit it at a certain angle so that it would change its course, and then if it needed, we would have to hit it again after a few days so that we could tell where it's going. And yeah, that's pretty much it. And then here is my bibliography on where I found all my evidence and work. Thanks guys for watching my video, and to look at my website is jmazur280.wixsite.com/asteroidawareness.